everyone, welcome back to my YouTube channel. So today we are going to solve day 12 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3272. Find the count of good integers. Okay, so let's read the problem statement first. You are given two positive integers n and k. An integer x is called k palindromic if x is a palindrome and x is divisible by k. Okay, so what is this palindrome? Okay, so an integer is a palindrome when it reads the same forward and backward. So here if you see the example, 1 to 1 is a palindrome while 1 to 3 is not a palindrome. Okay, so in case of 1 to 1, if you read from left to right, it is 1 to 1, and if you read from right to left, it is still 1 to 1. Okay, but in case of 1 to 3, if you read it from left to right, it is 1 to 3, but if you read it from right to left, it is 3 to 1. So different, right? So an integer is a palindrome when it reads the same forward and backward. Okay, done. So an integer x is called k palindromic if x is a palindrome and this x is divisible by k. So if x is palindrome and is divisible by k, then it is called as k palindromic. Okay, clear with this definition, right? Now next, an integer is called good. Okay, and we are finding what? We are finding the count of good integers. Okay, so now let's read the definition of this good. An integer is called good if its digit can be rearranged to form a k palindromic integer. For example, let's suppose k value is equal to 2. Okay, so here we have number this 2020. Okay, so 2020 can be rearranged to form the k palindromic integer 2002. Okay, so if I rearrange the digits of this number, so 2 is 2 times and 0 is 2 times. Okay, so if I write it like this, let's say, okay, so first of all, this is palindromic. Okay, this is a number x and this x is a palindromic, right? If you read from left to right and if you read from right to left, same number. Okay, this is done. Now this x is palindromic. Now we have to check if it is k palindromic. So we have k is equal to 2. Okay, so just divide this with k value. Okay, so yes, it is completely divisible by k. Okay, this number x, so it is nothing but k palindromic. Okay, so we rearrange the digits of this number like this. Okay, and this integer x is nothing but k palindromic, right? So this is nothing but this is going to be our good integer. Okay, we have to just find the count of good integers. Okay, so an integer is called good if the digits can be rearranged to form a k palindromic integer. For example, for k is equal to 2, 2020 can be rearranged to form the k palindromic integers 2002, whereas 1010 cannot be rearranged to form a k palindromic integer. Okay, so here if you rearrange the digits, okay, if you write like this 1001, this is palindromic, but it is not k palindromic because it is not divisible by k, right? Clear until here? Now we have to return the count of good integers containing n digits. Okay, so n value is given to us like here n is equal to 3. That simply means that we have to find out the integers having size 3. Okay, the digits having size 3, and these digits should be k palindromic, right? When we rearrange the digits, they are k palindromic, and we have to find such good integers. Okay, so we will see the example. Okay, so here note that any integer must not have leading zeros neither before nor after rearrangement. Okay, so note that any integers must not have any leading zeros neither before nor after rearrangement. Okay, so if you see 1010 cannot be rearranged to form 101. Okay, so there should be no leading zeros. Okay, done. All right, now see this example number 1. All right, here n is equal to 3 and k is equal to 5. Okay, so first palindromic. Okay, what are palindromes? All right, so here you already know the definition. Okay, so let's consider two cases: odd length palindromic and even length palindromic. Okay, these two conditions. Okay, so if I say n is equal to 3, so that simply means odd size, right? N is equal to 3. So here for n is equal to 3, whatever the number that we have here, okay, whatever the number that we have here, that same number should be here. Okay, and in between we can have any number. Okay, so if you see, this is the mirror image. Okay, this y is fixed, but here x, so here also x. So now if you read it like this or write like this, you will get x y x only. Okay, and in case of even, so let's suppose n is equal to 4, right? So in that case, if let's suppose a 4-digit number. Okay, so in that case, in even, Okay, so here if you have x, y, then this complete will be the opposite. Okay, so here you have y and here x. Okay, so mirror image line between here. Okay, this is nothing but mirror image line. Okay, so what I will do, okay, here what I will do now. All right, so now see here this in case of n is equal to 4. Okay, if I just find out the left part. Okay, if I just find out this left part, and after that I can just rearrange these two and I will get the right part. Okay, in case of n is equal to 4. Okay, I am asking about the digits of 4 length. Okay, so that simply means starting from 1000 to 9999. Okay, until here. Okay, so now here in between we have to find the integers. Okay, starting from this 1000 to 9999. Okay, so here in this case, if I just calculate the left side part, okay, then definitely I will get the right side as part as well. Okay, by rearranging. Okay, so what I will do here, so like this, so just left part na, so you need just left part. Okay, so left part simply means two sides. Okay, n is equal to 4, so just left part you need. So in n is equal to 4, so in left side you will have 2 digits, in right side you will have 2 digits, right? So that simply means for this, okay, you can just have this range 10 to 99. Why 10 to 99? Okay, so if you consider 10, then here you have to just create the mirror image, you will get this number. Done. If you consider 11, then here just mirror image, you will get 11 here. Then 12, then here you will get the mirror image 21. Okay, 13, so here you have to just write the mirror image, you will get this 4-digit number, and all these are palindromic only, all these numbers are palindromic only, right? All these numbers are palindromic. Okay, 14, then here just mirror image of this one, 1441. Okay, then 15, here 1551 you have to write. Then same way here if you write 99, so here 99. Okay, so with just these two integers, okay, 10 to 99, okay, you can form the 4-digit numbers. Okay, n is equal to 4. If n is equal to 4 case, then you have to just use 10 to 99, right? Done. Okay, all right. Now in case of 3-digit number, what you need to do? Okay, so if I say n is equal to 3, okay, n is equal to 3. Okay, so now in the left side part, okay, so let's suppose you have number like 1 2, so here you need just one. Okay, so you just need the mirror image of this one. Okay, so here let's suppose 1 3 1. Okay, here let's suppose 2 4, and here you just need this. Okay, so you should know this much part. Okay, for the left. Okay, so here in case of n is equal to 3 also you should know about this left part. Okay, of having size 2. Okay, and when you are going to create the mirror image, then you have to just create the mirror image of the first integer. Okay, then you are not using this one, right? You have to just create the mirror image of this one. Okay, so let's suppose you have number like 9 and here 7. Okay, now you have to just know about this. Okay, you don't have need to use this. Okay, so you will use this 9. Okay, so here left part size is 2 here also. In this case also left is equal to 2. Okay, so here also left is equal to 2, and for n is equal to 3, and here n is equal to 4 size also we are taking left part of 2 size, right? So from here I can write one formula to calculate the left side part. Okay, so how you need to get the left side part? So just uh, do one thing, whatever the n value, okay, in that n value just add 1, okay, and divide it with the 2. So now here just place 4. So if you place 4 plus 1 divided by 2, you will get nothing but 2 only. Okay, so this is a number of integers you are checking. Okay, for the left side, right? And if your n is equal to, let's suppose 3. Okay, so 3 plus 1 divided by 2, again you are getting 2 only. Okay, now you can take a 5 digit. Okay, let's suppose n is equal to 5. So here let's suppose your number is like this, 12912. Okay, so now you should know until here now, and here you have to just reverse these two. Okay, right? So here if you do the write the formula n plus 1 divided by 2, 5 plus 1 divided by 2, you will get 3. Okay, so if you know these 3, and here for odd number of cases you have to just reverse these two. Okay, for n is equal to 6, same way. So let's suppose you have n is equal to 6, so let's suppose this is palindrome 129, and here 921. Okay, so then also you are splitting in between. Okay, and if you apply the same formula, n plus 1 divided by 2, so you are going to get 6 plus 1 7, 7 divided by 2, you are going to get 3 only. Okay, so this is done. So this is one general formula that I have derived. Okay, so I'm going to create one variable, let's suppose d, and in this d I will just apply this formula, and this formula is going to give me the left side integers. Okay, done. Okay, now this is done. All right, now here if you see one more thing, how I am calculating this range, like for n is equal to 4, my range is going to be 1000 to until here. Okay, so I can say now my range is 1000, and let's suppose there is one number, okay, x, and it should be less than, here I can say less than 5 digit, okay, 1 2 3 4, okay, this 1 2 3 4 5, okay, until here, until 99. So how I can write this range? So start is going to be, I can say my start is going to be 10 raised to power 3, okay, so I can write it 10 raised to power uh, 10 raised to power n minus 1, okay, this is the range, but actually we don't need this actually, okay, so 10 raised to power, if you want to write it like this, okay, 10 raised to power n minus 1, and here 10 raised to power n, okay, until here. But for n is equal to 4, you are only dealing with this now, okay, you are only dealing with this part only. So instead of this, okay, we simplify our problem, okay, so we are just going to create the mirror image from here only, okay. So n is equal to 4, you need to deal with 10 to 99, okay, and then you are definitely going to, if you are going to create the mirror image, you are going to generate the 4 digit only. So then you have to deal with 10 raised to power here d value is nothing but 2, okay, so d minus 1, 10 raised to power d minus 1 is going to be the start, and 10 raised to power d is going to be the end, okay. So here like this, and it should be less than 10 power d, okay. So this is nothing but 10 and numbers, okay, x, and number should be less than 100, okay. So this is going to range 10 to the power d, d is 2, okay, in this case when your n is equal to 4, so d was coming as 2, okay. So we don't need to care about this, okay, so ignore this, okay, ignore this, we have to just deal with this, okay. So I will run one loop, okay, from start, okay, this is going to be my start. Let's suppose for n is equal to 4, okay, this is going to be my start, and this is going to be my end, okay. And in this start to end, I will run one loop, okay, and I'm going to treat this 10 as left half, then 11 as left half, 12 as left half, 13 as left half, 14 15, like this I will create the left half, and then I will just create the mirror images of this left half, okay, to form the complete number, okay. And then after doing this, okay, first writing this 10 and then doing the mirror image, so definitely all of these are going to be palindromic only. So okay, so palindromic only, I'm not saying k palindromic, they are going to be palindromic only. So now after that, this complete number I will also check now, I will also divide it with k, okay, whatever the k value that I have, whatever the k value I have, and I will divide that, okay, with k. And if it's completely divisible, then definitely that simply means that particular number is going to be my k palindromic, okay. So this is done, okay. How I'm going to create the palindromes, okay, this is the first part of this problem, how to create the palindromes. So using mirror image, so your n is equal to 4, so you have to just use integers from 10 to 19, okay, in this range only you have to run the loop, that's it, okay. Then create the mirror image, that's it, okay. And I'm going to use a string now, obviously I will use string only. So here it is easy to reverse the string, okay, 10, I will just reverse it and append it, okay. I will use string builder, right, and I will append that, right, okay. So this is done, all right. Now okay, now this is done. Now here this is clear how we are going to create the palindromes, okay. So now let's suppose I have this number abc, let's suppose. Now what are the different palindromes of this one? Tell me, what are the different palindromes of this one? Okay, abc, in how many ways I can note palindromes? Tell me permutations, okay, how many different permutations of this one, okay. Why I'm talking about permutations, I will tell you. First, permutation means different ways to write this, okay. abc, I can write it like this. I can write using this same number of integers, okay, whatever the digits we have, characters, okay. Here I'm using characters for just reference, okay. So here I can write bac, here I can write bca, here I can write ab, I can write, okay, I can write cba, okay, and anything else. There is one more, I can write acb as well, okay. So these are the six, right? abc, acb, bac, bca, cab, cba, okay. So here 3, okay, these 3, okay, total size is 3, okay, n is equal to 3. So here n is equal to 3. So in how many ways I can write this abc? So here, that here at this particular position, I have choices, and I can write a, I can write b here, I can write c here. I have 3 choices here, okay, 3 choices here. All right, done. Now if one choice is fixed here, then I have only 2 choices left, okay. So here I have 2 choices, and here I have just 1 choice, so overall 6, okay. So this is the simple way to calculate the number of permutations. So that is nothing but 3 factorial, okay. This is also one mathematics concept, right? Permutation combination chapter, you have studied in the ncrt textbook, I think class 10th, right? There was one chapter on this permutation combinations, okay. So different type of permutations, okay, for this, all right. So 3 factorial, 3 factorial is nothing but 3 into 2 into 1, okay. So there are 6 ways to write this abc, okay. So see, all these strings are containing only a, b, and c only, and there are 6 ways to write this, okay. Now why here I am talking about permutations? Why I'm talking about permutations here? Okay, and here we are talking about palindromes. Okay, here we were talking about palindromes in this part. Okay, so now here, see this number. Okay, let's take this number 551, sum of the good integers. Okay, n is equal to 3, k is equal to 5, output is 27. It is saying that 27 good numbers are there. Okay, 3 digits number we have to find out, okay, which are good. So you already know the definition of good. Okay, first thing, that the number should be palindromic. Okay, if we rearrange the digits of that particular number, and that digit should be divisible by k to make it a k palindromic. Okay, so if though these conditions are satisfied, then that particular integer is good. Okay, so it is saying that 551 is a good integer. Okay, 551. So why 5551? So first of all, it arranged it like this. Okay, 515. Okay, then it divide this number with k. Okay, so completely divisible. So that's the premise that this makes it a good integer, right? Okay, so now here, okay, so 515. Okay, 515, right? 515. Okay, so now here I can write this 515 as 551 is also good integer, right? 155 is also good integer. See, why 155 is also good integer? So see, I can write this 155 also as 515. I can write this 551 also as 515. Okay, and I also can write here 5. Okay, yeah, 3 ways only. Okay, because here there is one duplicate, right? There is one duplicate only. That is why you are taking the 3 numbers, not 6. Here you are getting 6 numbers. Okay, 1 2 6 combination. Okay, 3 4 5 6. Why? Because all are different, a b and c, but here these two 5 are same. Okay, so how we remove the duplicate elements? Okay, so in how many ways I can write this 5 so there are total 3 ways only, right? These 3 ways only, right? So how to do that? Simple. Here total 3 factorial, and here we have to just write the, below that we have to divide it with the duplicates, okay, or the count of all the elements. So this is also mathematical concept. So 5 is occurring 2 times, so here 2 factorial, 1 is occurring 1 time, so here 1 factorial. So overall 3 into 2 into 1. Okay, and here 2 into 1. Okay, and here 1. All right, so cancel out. Okay, so overall we get 3. So there are total 3 ways only. So using this 551 also I can form this 515. Using this 155 also I can form this 515. Okay, so both are good enough, right? So that is why I'm talking permutations, because let's suppose, okay, let's suppose this abc is a k palindromic. Okay, so using this bac, using bca, using cab, cpa, acb, I can form this, right? I can form this. So these all are going to become nothing but good integers, right? Because I can arrange the letters of these particular combinations, okay, like this. Okay, and let's suppose this is divisible by k properly. That makes it good. Okay, so that's why I'm talking about permutations here, right? So now let's take one more example. So this is for this one. Okay, so here 5 to 5, because it is already k palindromic. Okay, so so these are some of the good integers. Okay, and here example number 2. Okay, so n is equal to 1, size is 1. Okay, so you only 4 and 8 only, right? Because 4 is also divisible by 4, k is also 8 is also divisible by 4. That's so only 2. Okay, two good integers are 4 and 8 because size is 1 now. So it's very easy example. Same way here, n is equal to 5, k is equal to 6. 2 4 6 8. Okay, so let's take this example. Okay, so let's take one number. Okay, let's say you have number like this, 2 4 6 4 and 2. Okay, so this is a palindromic number, right? And this number, let's see if it is divisible by 6. Okay, so here 6 4 24. Okay, 6 1 6, then 0 and 6 7. Okay, so yes, this number is divisible by 6. Okay, so if you just 7 6 42, 4 here, 6 here, and 2 4 6 4 2. Okay, you are getting this. Okay, so this number is completely divisible by 6. Okay, so here now this number is a k palindromic, right? This number. So now here, what are the different combinations in which we can write this number? Okay, so different permutations. Okay, so you know that, right? 1 2 3 4 5, so 5 factorial, right? And here downwards you have to just write the count, okay, of all the numbers, so that we do remove the duplicates once. Okay, so you already know that how we are removing duplicates here. Okay, so here all the numbers are distinct, we were getting 6, but here in this case 551, size is same and equal to 3, but we are getting only 3 different ones. Okay, because there are some duplicates. Here see, first you are writing this 5, and then you are writing this 5 and then 1. Okay, and in other example, first you are writing this 5 and then you are writing this 5 1. Okay, but these are duplicates, huh? You don't need to count that, right? So that's the reason. Okay, so here 5 factorial, and 2 frequency 2 is occurring 2 times, 4 is occurring 2 times, and 6 is occurring 1 time. Okay, so here if you see here, okay, so here you will get around 30, right? 5 into 4 into 3 into 2, okay, and here 2 into 2 only, this cancel out this, 5 3 15 20 30, okay, 30 you are going to get. Okay, this is done. Okay, so for all these 30, okay, for all these 30 different these combinations, okay, different combinations, these are going to be become good integers only, right? Definitely they are going to become good integers from, because from this one also we are going to generate that particular good. Okay, this from also we can generate good. Okay, this one is from also we can generate a k palindromic. Okay, and this is already a k palindromic, so all are good, right? So all 30. Okay, but now let's suppose, okay, while forming this n is equal to 5, okay, so n is equal to 5 simply means if you calculate the left half, so you have to calculate the half first, left half. This is the formula na? D is equal to n plus 1 divided by 2, so you get 3. Okay, so 3, right? So 3 digit number, so you are searching from 1000 to 999, okay, until here. So you get this 246, and for this you generate this 42 here, this number. Okay, but later on you write this 42, and in between you use 6, and again you generate the this half opposite. Okay, 24. Okay, so here in both these numbers, if you see, 2 is occurring 2 times, 4 is occurring 2 times, 6 is occurring 1 time. Here also in this number, 2 is occurring 2 times, 4 is occurring 2 times, and 6 is occurring 1 time. Okay, so if you write a few of the examples, okay, so from this number you can also write 2 4 6 4 2, right? So you notice one thing, that here again we are getting duplicates. Okay, these numbers we have already counted all the different permutations for this one. Okay, we have already stored them into our result. Now for this number also it is going to generate the same things. Okay, few same numbers, right? So what we are going to do, uh, what I'm going to do, I will just sort this. Okay, this is going to be my string now. So in this string I will just sort all the characters. So what I will get, 2 2 4 4 6, and here also I will just sort them. So what I will get, 2 2 4 4 6. So now after sorting I will just add them to one set. Okay, so you already know that in set we can't store the duplicate numbers, so I will just add this one particular number. I will not add this. Okay, I will not add this. Okay, so by generating the palindromes, okay, I will take care of this thing while generating the palindromes. Okay, for all the numbers I will just sort them. Okay, and after sorting I will just push them to the set. Okay, and then after that inside set I will iterate over all the palindromes, right, one by one. And then, okay, so one thing here, I will generate step one, I will generate the mirror images. Okay, palindromes mirror images. Okay, palindrome mirror images, this is one thing. Okay, after generating the palindromic mirror images, now the second thing that I'm going to check, I'm going to check if this is a k palindromic. Okay, so I will divide that particular number with k. Okay, so if it is not palindromic, then skip, then we don't need to do anything. Okay, but if it is a k palindromic, then after that what I'm going to do, I'm going to sort the characters of this k palindromic. Okay, sort the characters of k palindromic. Okay, and after sorting the characters of this k palindromic, fourth step, just add them to set. Okay, so I hope that you guys are clear until now what I'm doing, creating the palindromic palindromes using mirror. Okay, mirror images. Then I'm checking that whether these are k palindromic, and then after that I'm just, if they are k palindromic, I'm sorting the characters of that k palindromic, and then I'm adding them to set. Okay, done, done until here. Okay, this is done. All right, now in the set we have added everything. Okay, now inside the set I will just check all the numbers. Now we already know that they are k palindromics. Okay, so in the set what I will do, okay, so in the set, okay, so let's suppose I have this number 24642. Okay, 24642. Okay, so how I'm going to calculate the different type of numbers, okay, that I can generate. Okay, good integers. So for this particular number, different number good integers, I know na that formula. Okay, 5 factorial, 2 factorial, 2 factorial, and 1 factorial I have calculated. Okay, so we are getting just nothing but 30, right? Done. Okay, so now here this is one thing. Okay, in this number you don't see any zero, but now there is one issue. Let's suppose there is one number like this, 20, then here 6, and then 02. Okay, now here if you calculate the different type of ways to write this. Okay, so again you are going to do the same thing, 5 factorial, 2 factorial, 2 factorial, and 1 factorial. Again you are going to get 30, right? But this is wrong here. Okay, you can't write this 0 above here at this position. Okay, you can't form number like this 262. Okay, this is not right way, because this is a leading 0. Okay, so no leading 0 should be there, right? You can't write number like this. Okay, you can't write number like this. This is also wrong. Okay, just 1 0 2 0, this is wrong. We don't need to calculate this. Okay, so now how to skip this? Okay, how to skip this thing? So here 5 digits only we have to form now. So here why we were writing 5 digits? Because here at this position we can write 2 4 6 4 2, that is why 5 ways. Now if I write something here, then I have only 4 options. If I write 2 things here, then I only have 3 options. If I write 3 things until here, then I have 2 options. If I write all the things here, only 1 left, so I have only 1 way. Okay, this is a way for the all the characters are unique. Okay, all the digits are different. But now duplicate scenario. So in order to overcome the duplicate scenario, what we did, we just calculated the frequency of all the numbers, and here just added that, like 4 is occurring 2 times, 2 is occurring 2 times, and 6 is occurring 1 time. Okay, we did this. Okay, so now here same way, if I draw this, okay, so 1 2 3 4 5. Okay, so now at this first position, okay, at this first position, okay, we can't write zeros. Okay, we only have 3 options. Okay, we only have 3 options in first position, right? And then afterwards, okay, here we have only 3 options. We can write 2, we can write 6 on 2. Okay, then afterwards we have options like same options now. After that I can write 4 4 3 into 2 1. Okay, why 4 3 2 1? Because here I have option now. If one number I used here, so here I can write any other number. Okay, I can use 0 as well, no issues. Here if until here if I write 2 numbers, here I will have 3 options. Okay, but here only in this first position only I have problem, I can't use 0. Okay, so here, and also you have to write here duplicates as well. 2 is occurring 2 times, 0 is occurring 2 times, and 6 is occurring 1 time. Okay, you have to write all this same stuff. Okay, so now how you are going to do this, how you are going to this? Okay, so I will derive one more formula, okay, using these two examples, 2462 2062. So here in this case, can you write it like this? 5, okay, can you write it like this? 5 into 4 factorial by 2 factorial, 2 factorial, and 1 factorial. You can write it like this as well, right? And can you write it like this? 3 into 4 factorial, 2 factorial, 2 factorial, 1 factorial. Okay, so now here if you see this part here, and if you see here this part, both are same. Okay, so only at first position we have here 5 options, and here we have just 3 options. This is the issue, right? So now here in general, what I can say, this 5 is nothing but the non-zero integers here, and here this 3 nothing but non-zero integers here. So I will do that now. I will just calculate the non-zero integers. Okay, so here I will use one variable, and you can say give any name to that variable. Okay, I will say non-zero digits, nzd. Okay, so this is nothing but nzd. So done, clear here. What is this nzd? Nzd is nothing but non-zero digits. Okay, and then same formula. Clear, done. That's it. That's it. So much maths is there in right in this problem. Okay, so these are the steps. Palindromic mirror, k palindromes, continue if they are not k palindromic. Otherwise, just sort the characters of k palindrome so that we don't add the duplicates into my set. Okay, then add them to set. All right, and then just iterate over the set. Okay, and then just calculate the number of ways, 30. So add 30 for this particular number, and we definitely don't have any duplicate for this particular number. Okay, we don't have 4 2 6 2 4 in our set. Definitely it's not there. Okay, so for this only we are good if we calculate 30. Now next number. Okay, so this is what we do. Okay, and now how we calculate the palindromes, last step. How we calculate the factorial of a number. So factorial until we have n value given, right? N is uh, until 10 only. Okay, 1 to 10. Okay, so I will just calculate the pre-calculate the values. Okay, factorial, like 1 factorial is nothing but 1, 2 factorial is nothing but 2 into 1, that is 2, 3 factorial is nothing but 3 into 2 in 2 factorial, that is nothing but 6. Okay, 4 is nothing but 4 into 3 factorial, that is nothing but 4 into 3 factorial is 3 to 1, that is nothing but 6, so 24. Okay, and what is 5 factorial? 5 factorial is nothing but 5 into 4 factorial. Okay, so 24 into 5 you will get 120. Okay, right, 24 into 5, 5 for 20, 5 to 10 20. Okay, so here see 2 is nothing but 2 into 1, 3 is nothing but 3 factorial if you calculate, that is nothing but 3 into 2 into 1, okay, 6. Okay, so we will just calculate until 10. I will just calculate, okay, and then I will directly call this. Okay, so I will directly store that 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, and 5 factorial is 120. Okay, and you already know how we calculate the factorial, right? So 4 is nothing but 4 into 3 factorial, previous factorial. Okay, 4 into 3 is factorial, 3 is nothing but 3 into this 2 is factorial, 2 is nothing but 2 into this 1 factorial, 5 is nothing but 5 into this previous 4 factorial. Okay, so I will just calculate all these values previously, okay, in the starting itself. Okay, so now let's move to the coding part, and I will explain all the code part as well. Okay, so I will make this problem easy for you. Okay, so first of all, we have numbers until 10, right? So I need a factorial from 1 to 10. Okay, so here just create one factorial array. Okay, long factorial array. Okay, new, and here long, and here add the size as 11. Okay, 1 to 10 we need, right? And you already know that factorial of 0 is going to be 1 only. Okay, factorial of 0 is 1. Okay, and now just run one loop for int I is equal to 1. Okay, from 1 we need until 10. Okay, so here you can write I is less than 11 or less than equal to 10. Okay, whatever you want. Okay, I plus plus, and here inside this, how you calculate the factorial of 1? So factorial of 1, that's nothing but I current I, so it is nothing but the current I value. Okay, in that you have to add the factorial of I minus 1. So very easy now. So I have already explained previous value. Okay, factorial of I minus 1, and we already know the factorial of 0, so I will get 1. Okay, same way for 2. So 2 into, we already know the 1 previous times, then 3 into 2 factorial, we already know previously, right? So this is what how I'm going to fill this factorial, okay, array, right? So in competitive exams we used to do the same thing, okay, because it will save much time, right? Right, okay, done. Right, now after that create one set. Okay, so set and string, and let's name it as set only. New hash set. All right, and then left part, how you calculate n plus 1 divided by 2, that's it. So I already told you why we are doing n plus 1 divided by 2. Okay, so this is done. Then your start and end. Okay, so start, how you calculate? So math dot power. Okay, math dot power, and here 10 raised to power d minus 1. Why? Okay, I have already explained this as well. Let me just point it where I explained this. 10 raised to power d minus 1. Okay, see here, I have explained this, why we are writing 10 raised to power d minus 1 until d. Okay, for 4 we only need first two part. Okay, done. So this is done. Okay, and end the same way is equal to int, and here math dot power. Okay, and here you have to write 10 raised to power d. Okay, and here just subtract 1. Okay, because 9999 until here we need, right? Here, okay, we are taking this example 10 to 99, so 10 to d minus 1, and here 10 to d we are getting now, but we need not 100, we need 99. So in this 100 I subtract 1, that's the reason. Okay, so I hope that you guys are clear until now. Okay, this is not very easy, code is going to be very easy for this. Okay, so now after that we have to just iterate from start to end range, right? So int num is equal to start, right, and num is less than equal to end, and num plus plus. All right, and here inside this left half, so how you going to calculate the left half? String left half is equal to integer. Okay, whatever the number you have. Okay, you have to convert that to string first. Okay, because it will be easy for me to use string filter and reverse that particular number. Okay, so I just convert that number to string. Okay, here I just pass that particular number. Done. All right, and then after this what we need to do? Okay, so we have to calculate the full number. Okay, so left half, now we have to generate the full number. Okay, so first of all I will check if I can do completely divisible this number with the 2. So I will check now odd or even. Okay, so if n modulus with the 2 is equal to 0, that simply means that this is an even number, so I need complete reverse. Okay, so even number now, so n is equal to 4, so 10, so here I'm writing 0. Okay, so I'm reversing this complete reverse of left half. Okay, so here what I'm going to do, string builder, string spelling mistake, string builder. Okay, here right half is equal to new string builder. Okay, and now after that, what I'm going to do, left half. Okay, whatever the left half that I have, I'm just going to reverse it. So that is going to be my right half. Okay, if I reverse it, now here in the full, okay, I will just add now, I will just append. Okay, so here what I will do, left half. Okay, left half plus, okay, so it will just concatenate. Okay, so here half right half dot to string. Okay, to string, done. Okay, so this is done. So this is for even. Now for odd, so just copy this. Okay, and here you have to write else, and here string builder right half is equal to new string builder left half. Now there is one restriction. Okay, for odd, so we are not reversing this complete, we are only reversing the until here. Okay, we are not reversing the middle one. Okay, this one, right? Same way here n is equal to 6, we are reversing this complete, but here if you take n is equal to 5, so we are reversing until here only, right? So what I'm going to do here, I will just pick that particular substring. Okay, so here new string builder, and here left half dot substring, okay, which is starting from 0 until, okay, d minus 1, d minus 1. Okay, and I'm just going to reverse that, and then I will get the my full. Okay, this is done. Okay, now to get the full complete number, so I will just write long number is equal to long dot parse this long. Okay, parse long, and here I will just pass this full string. Okay, I will just convert the number to long, and I will just divide this number. Okay, if number modulus with k, now I'm checking whether this is k palindromic or not. Okay, number modulus with k is not equal to 0. Okay, so if it is not palindromic, then you have to simply continue. Okay, otherwise if that is not the case, then you have to sort the characters. Okay, and we already know why we are sorting the characters. Okay, so I have explained that using this example. Okay, I think, yeah, 2 4 6 6 4 2 and 4 2 6 4 2. Okay, so we are getting duplicates, right? Here also same number of elements, same number of elements. Okay, so I will explain this part as well. So that's why we are doing the sorting. Okay, so I hope that you guys are clear until now, right? So char, and here chars, you can say full dot to char array. Okay, this is done, and then just sort now. So arrays dot sort, and here chars. Okay, and then after that in the set just add this. Okay, set dot add new string, and here chars. Okay, so this is done, right? Okay, so this is done. Now after that, here now we are done with the complete process. Okay, now we have to just add the different type of permutations. Okay, so we know the k palindromes that we have, that this is one k palindrome, so we have added all that to my set. Okay, whatever, wherever it's possible. Now from all different permutations of this one, we can get this particular, right? So we have to make the count. Okay, so I'm going to create the long result is 0. Okay, now only few lines of code is pending. So this problem is very easy, right? Here if you are clear with the mathematics part now, then this problem is easy. Okay, so here for string, and here s set. Okay, and here inside this you are going to iterate over all the set elements one by one. Okay, all the set strings one by one. So now in those strings you have to also calculate the frequency of all the characters, so in order to remove the duplicates ones, right, from the permutations. So in order to do that, create one count of array. Okay, count new int, and we have numbers from 0 to 9, right? So here you can write 10. Okay, and here just iterate over all the characters in that particular string. Okay, char ch in s2 char array. Okay, and now here inside this you have to count character, and if you subtract 0 from it, you will get a particular number, and for that particular number you have to increment the frequency, right? So in this way you have to calculate the frequency. Okay, now total digits we have to get. Okay, so we have to calculate the total digits, 0 digits, non-zero digits, right? We need that. But why we need that? So I already shown you here somewhere here. Yeah, here nzd. Okay, non-zero digits we are writing, and we drive this formula. So this is what I'm doing now. Okay, so int total digits is equal to s dot length outright, and int 0 digits is equal to count 0. Okay, so this is just going to give me the 0 digits count. Okay, so I have already stored the counts of 0, right? And non-zero digits we need, right, basically. So int non-zero digits is equal to total digits minus 0 digits. Okay, so this is going to give me non-zero digits. Now just calculate the permutations. Okay, int permutations is equal to, so same formula that I have derived previously, non-zero digits multiply with factorial. Okay, factorial, and then after that you have to start from 4 now. Like if in case of 5 digits you have to start from 4 now, first non-zero digits. Okay, then starting from 4. Okay, so that's 4. I can say total number of digits minus 1. Okay, total digits minus 1. I can say factorial of total digits minus 1. Okay, so this is going to calculate the permutation. Okay, now duplicates we need to remove, right? So we have to divide this permutation with duplicates. Okay, so that here we need this now. So 5 into factorial, this is done. Now we need this part. Okay, so what I'm going to do here, I will just iterate over the frequency that we have calculated of all the elements. Okay, for int I is equal to 0, I is less than 10, and I plus plus. Okay, we have numbers from 0 to 9, right? And here whatever the total value that open we get, okay, so I will divide it every time with the factorial of that count. Okay, factorial of count of that particular number. Okay, count of I can say, right? This is done. Okay, and then every time, okay, we have to add this to the result. Okay, so result is equal to result plus permutations. Okay, overall result is I'm adding it to the permutations. Okay, and then after that we have to just return the result. That's it, return result. Okay, that's it. Now let's run the code and see if there are code issues. We'll try to fix that. Okay, incompatible types possibly lose the conversion from long to int. Okay, long to int. Okay, so here do one thing na, instead of int, okay, take long here. Okay, long. Done. Now let's run it. Done. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.